So convenient sample is just like it sounds, convenient. So the person collecting the data is able to capture people who are close at hand and easy access. So for example, at the mall, if I was running a survey, maybe about shopping trends or something having to do with mallish type things, I would go to the mall and capture people there by sort of stalking them out in the hallway in the corridor. Or if I'm in class and I want to choose a convenient sample, I might just choose all the kids in the front row. So we're going to talk a little more in depth about number 4, which is simple random sample. But just know, and I'm going to put this in a different color, that this is the best choice for sampling because it allows for the least amount of bias. And we're going to talk about what the components for that are in just a second. Stratified random sample is to take a random sample, but before I actually take that random sample, I'm going to group people by some characteristic. An example of this might be to pick, let's say, 5 kids from every class. So first, I would sort by grade level, and then I would randomly select from each of those grades. So I would put all the freshmen together in a hat, I'd put all the sophomores in a hat, juniors, seniors, same thing, and then I'd pick 5 out of each grade level so that I'm sure to have 5 for every grade level as opposed to 20 kids at random. And then multi-stage sample is I simply do that strategy more than once. So let's say, for example, I wanted 40 kids as a random sample from OSOS. I might first sort them by grade level, and then I'd sort them by gender. So knowing that I want 10 from each to get my total of 40. And then out of those 10 freshmen, I'm going to sort and do 5 girls. So I'll randomly select 5 girls and randomly select 5 boys. So I maintain the balance in every grade level. So now for the proper definition for a simple random sample, it must have 2 components, and you will always be quizzed on this by both me and the AP test. So the first one is that every person in the group has to have so an example of that would be that I put all the girls and all the boys into a hat. But the reality is, if every person in the group has to have the same probability of being chosen, there has to be an equal number of girls and an equal number of boys. And then every subgroup, well, the minute I go to, okay, let's rephrase that. That was actually a bad example because the minute I start sorting boys and girls, I'm already stratifying. So simple random sample is put everybody's name in a hat, draw their names out of a hat. Reality is every person has the same probability of being chosen, 1 in however many are in that hat, and every subgroup has the same probability of being chosen. Unlike when I stratify, I can't have every subgroup chosen because if I were to put all the boys in one hat, so imagine the boys' names are in there, and all the girls' names in another hat, pretend this actually is a hat. So I have boys in here, girls in here. I can't get all girls if I'm purposely selecting, let's say, 5 and 5. The probability that I get 10 girls is 0. So that subgroup doesn't have the same chance of being chosen as 5 girls subgroup does. We'll talk more about this in class.